Hello everyone, welcome to Education in Hands. In this first video, if we see the learning outcomes, let us introduce to the concept of limit state design of steel structures first. Then we will see the difference between analysis and design. Then what are the materials we are going to use in the design or in construction. And next we will go to our important material, that is steel. So what is steel and what is its chemical composition, and then what are the types of structural steel we are having in our Indian standards or in general practice. So first, what is limit state design of steel structures? Limit state design of steel structures was introduced in 2007 in India along with the code IS 800-2007. Previously, we used to design the steel structures using working stress method. But here in this IS 800-2007, we used to design the steel structures using limit state method. That's why it is called as limit state design of steel structures. This design of steel structures is carried out on the members in a structure when analysis is over. So if we see the difference between this analysis and design, first, analysis, it refers to the determination of various forces and moments present in a member like shear force, bending moment, torsional moments, or axial thrusts, etc., due to the action of loads and their combinations. Whereas the design, it refers to the selection of size and shape of the member and its connection details like beam to column or beam to slab, etc., to resist the movements and forces that are determined in the analysis, and as well as it ensures the safety and economy of the structure. Here our course design of steel structures belongs to the design category in civil engineering. So whenever a design is carried out on a member in a structure, for the shape and size we need to select the material. For that we are having different civil engineering materials in our construction like timber, masonry, and majorly used concrete, which is in the form of mass concrete or RCC or pre-stressed concrete, and some elements like glass and plastics. Everything is available as a material. So we can choose any material. So here our prime course is on steel structures. So here we are focusing on steel as well as it is structural steel. So what is the difference between this steel and structural steel? We will see. First, what is steel? It is an alloy of iron and carbon to improve its strength and fracture resistance. So if we say steel means it is an alloy of iron and carbon. Carbon is added in very few percentages. And also in some few percentages, some other materials like magnesia, silica, phosphorus, nickel, and copper are added to modify the specific properties of steel. So if we see the chemical composition of steel, according to IS code 2062-1992 and IS 8500, grade of steel and its chemical composition is given like this. So first from Fe410 to Fe590, here we are having compositions of carbon to silica, which is provided in terms of carbon equivalent. So if you see what is the carbon equivalent means, it is derived from this formula C plus Mn by 6, Cr plus Mo plus V by 5, Ni plus Cu by 15. Here carbon C, manganese Mn, chromium, molybdenum, vanadium, nickel, and cuprum or copper. So all together added in certain percentages, and we will show it in the carbon equivalent to modify the specific properties of the steel. So this is steel. What is structural steel? If we see the structural steel, it is the category of steel used for making construction materials. So in our required shape and required form, when we are converting the steel, then that product or the material is called structural steel in varieties of shapes. See, depending upon the use of steel, structural steel is classified into various categories. So if we are using for one purpose, then that structural steel is having one property. If we are using for any other purpose like high strength or high yielding, then it is having another property. So whatever the type of structural steel, the structural designer is in the position to select the structural steel for particular application. So if we see the different types of structural steel, here we are having various types starting from carbon steel to fire resistant steels. So we will see one by one what are the types of these steels. First one is carbon steel. So what is carbon steel? This steel is the basic steel which is an alloy of iron and carbon. See here, carbon and steel are main strengthening elements. Its minimum ultimate strength is maintained at 410 to 440 megapascals, and its yield strength is nearly equal to 230 to 300 megapascals. It is the basic steel used in our construction or in RCC. Carbon steel. It is confined to Indian Standard Code IS 2062. Next one is high strength carbon steel. So here carbon percentages are added a little more. Steel has high carbon content. With this high carbon content, the main problem is it reduces the ductility, toughness and weldability of the steel, but it shows high strength. So this type of structures are specified for certain applications like construction of transmission towers or microwave towers where it need high durability and high strength. Its ultimate strength ranges from 480 to 550 megapascals, and its yield strength varies from 350 to 400 megapascals. Next one is medium and high strength micro alloyed steel according to IS 8500. So what is this steel? Steels are low in carbon content. Okay, this is a low carbon content steel, but it achieves high strength due to the addition of certain alloys. What are those alloys? Niobium, vanadium, titanium, boron, etc. Like micro alloying elements are added along with carbon to the steel, which increase its strength. Ultimate strength of this steel is ranging from 440 to 590 megapascals, and its yield strength is from 300 to 450 megapascals. Next one is high strength quenched and tempered steels. So what they are doing here, steels are heat treated to develop the high strength. These steels are very tough and weldable, and it requires some special welding techniques, not like general welding techniques. Here, if we see the ultimate strength, it suddenly increased to 700 to 950 megapascals, and its yield strength is also around 550 to 700 megapascals. The next one is weathering steels. Weathering steels are like low alloy atmospheric corrosion resistant steels. So steel is having one bad habit, that is corrosion. So this kind of steels are like low alloy atmospheric corrosion steels. These are often left unpainted. Its ultimate strength is around 480 megapascals, and its yield strength is around 350 megapascals. The next one is the stainless steel. We all know this application and we all know this name, that is stainless steel, majorly used in our household appliances or utensils. See, what is the stainless steel? This is essentially a low carbon steel to which a minimum of 10.5 to 20% chromium and 0.5% nickel is added. So after the addition of chromium and nickel, the steel will become stainless steel. See that property, it is perfectly rust proof and it is used majorly in our home utensils or any home appliances. Next and last one is fire resistant steels. We know steel is prone to fire, but here they show fire resistant steel. What is the difference here? Thermomechanically treated steel means it is a special process in preparing the steel bars or elements. Thermomechanically treated. Whenever a steel member is treated like this, then it will become fire resistant steel up to certain point. They perform better than ordinary steel under fire. It is not saying like completely fire resistant, but they perform better than ordinary steel under fire. So this is the various types of structural steel and their classifications. So next we will see what are the different structural steel products according to our Indian context and how we are denoting them. We'll see in the next video. Thank you.